Hello, good morning, everyone. Good morning, good morning, good morning. So, we're gonna have a discussion about Unit 2 algorithms and flowcharting. Office chat to prepare. Okay, and then, yeah, that's it. Chat box is here, and we're gonna share this to the Facebook. Have some preparations here. Going to already the share screen, and okay, so we're ready to start, and we are going to share our screen. So we're already sharing our screen, and we're gonna adjust the screen first. Okay. Okay, so welcome to Unit 2 algorithms and flowcharting. So you have this, you have to thank Mom Lynn Goldman for this module. And in this unit, you will explain how algorithms and flowcharting help a programmer solve a computing problem. No? This will also discuss relational and logical operators as well as looping construct. So at the end of this unit, you'll be able to explain algorithm, describe algorithm and flowchart as a programming tool, illustrate conditional and looping constructs, solve the given problem using flowcharting symbols. Using flowcharts, you can create flowcharts also. Then you have the pre-test. By the way, guys, the pre-test, you have to answer this one, the pre-test, and you're going to compare your answer to the correct answer at the end of this unit. No, so when I'm going to receive the module, hopefully you already have the check. You check that already. You have to check already that because that will test your present knowledge of that particular topic. It's not necessary that you have to read first the content before answering this one. Do not read the content first and answer this one based on your existing knowledge. So there you go. You're going to create a step-by-step procedure in sending an email message. So you already have your Gmail, your Google Mail, and probably you're gonna list the steps there. So this is somewhat like you're going to create an algorithm for sending an email message. Okay, so after that, you're going to create a flowchart based on your answer in number one. And most likely, if you're not familiar with this, you can leave blank on it. It's just okay. And or you may idea what a flowchart is. It's okay to make mistakes here when you're on the pretest because that is your knowledge in that particular topic. So thank you. So you have to look answer at the page 34 of your module. And let's proceed now. This is the content. To read this one, and I'm going to do my best to explain this to you in Filipino or in dialect in order to gain a more understanding on this particular topic. So, problem solving. What's problem solving? I'm gonna read this one. In facing our daily lives, we encounter problems. Yes, that's true. Some are easy to handle, some are complicated that it takes time to solve. Yeah, it's true. We have problems, and in order to solve these problems, we must have our problem solving skills. So, problem solving is always a part of our daily activity, such as deciding what to eat, how to pay your purchase products, how to clean the house, and the likes. We will find out how to solve problems by using algorithms and uh, yeah, use solving algorithms. So, by the way, talking about problems, you remember in our planning, if you're going to create a program or something, you need to look for a problem and you need to find a solution for that particular problem. And if you can address that particular problem based on creating a program or creating a service, that will make you uh, rich. It will make you rich if you can solve that particular problem. You have to remember that uh, the bigger problem is uh, the more opportunities you will have, the more income you will have if you have a bigger problem. And like for example, in Jollibee, the problem that Jollibee is solving is what? Food, no? Food. It's a fast food chain, and we pay for that particular hunger. Another problem, hunger. We pay for that, and Jollibee is having an income for that particular problem. And the Gmail, the problem for, let's say for example, the Google Mail, the problem is distance communication. That's the solution. So it's a solution for the problem with the snail mail. When we talk about snail mail, that is the usual mail when we send our letters to the postmaster, and we could receive that particular mail in a longer time. So with the use of the email technology, that's the solution. And the problem with the long distance and the delay of reaching the letter to the sendee will be solved using that Gmail. Okay, so let's proceed now to algorithm. So we have the algorithm. According to MADI 2013, algorithm is a sequence of activities to be processed for getting desired output from a given input. So it is a step-by-step procedure to solve a particular problem. An algorithm must be specific and it should have a starting point and it should terminate or end. So there's an example here. Um, we have a simple problem, frying a fish. So the first procedure there is rub salt all over the fish. Let's assume that the fish is already clean. You're able to, uh, when you have the fish, you have to remove the scales. You have to cut some of the, it's not wings, no, the, what do you call that? You have to cut um, the other parts there. And yeah, you have to remove the intestines. And after that, let's assume you have, the fish is already clean. So for the number one procedure, you have rubbed salt all over the fish. So the salt is, thank you very much. And Jane, Lumanda, thank you for coming. Thank you for coming here. And yeah, let's proceed. So you're gonna rub salt all over the fish. After that, you heat oil in a frying pan. Let's assume the frying pan is already clean. And when the oil gets hot, put the fish in the frying pan. Yeah, you can ask question. Fry the fish in each side for 5 to 10 minutes. So 5 to 10 minutes. Then remove the fish from the frying pan and put in the plate and serve the fish. Yes, you can ask question. So this one is an algorithm, and your output here is a fried fish. That's your output, and the processing is you have here the, when you put the fish in the pan, and the input there would be the fish. You can have the oil, you can have the other ingredients, no? Okay, so here, by making the steps clear, it will now then be easy to solve the problem. So another example is how to calculate the interest of a bank deposit. So to solve this, we need to follow the process, get the whole amount of money deposited in the bank, and then decide on how many years you want to keep the money, get the interest rate of the bank here. So you have the calculation, you calculate the interest using this formula. The interest equals amount of money times years times rate. And you can display, actually you can add here, display the interest you accumulated for that particular years that you choose. Okay, so that's all guys, that's algorithm. I hope you understand how uh, to create an algorithm. Okay, so let's proceed now to flowchart. So flowchart. So I have here, your flowchart is a graphical representation of an algorithm. It describes the operations required to solve a given problem. So an algorithm is just a sequence of steps in a solving problem, while flowchart can be used to represent algorithm graphically according to Programmist 2018. So we have different symbols for creating a flowchart. And yeah, we have this one, the flow line. It indicates the flow logic by connecting symbols. So this one represents the start and the end of the flow chart. And here we have input output used for the input and output operation. And we have this one, the rectangle processing used for arithmetic operations and data manipulations. Then we have the decision used for decision making between two or more alternatives. Then we have the on-page connector, and it is used to join different flow lines. You're going to connect, let's say for example, you have that on a paper, on this particular part of paper, and then you can connect here. You can use this one. You can connect on this other part, on the part of the paper. That's the on-page connector. Well, the off-page connector, let's say you have another page. You will use this one. And we have predefined process and functions. So these are the different flowcharts symbols. Yeah. If you already submitted your module through email, you don't need to pass that in Dropbox. You don't need to submit that on Dropbox. The Dropbox is only for those who have problems with internet connections. So you can submit your answers through Dropbox. But if you have problems with, if you have no problems with internet connectivity, you can submit that through Gmail, or you can submit that also in the, what do you call this one, in our Google Classroom. Okay, so we have an example now. Let us create flowchart using example algorithm above on bank interest. So this one is the start. So you have to write the start. You draw this one. Actually, you can use pen and paper for this, or you can use um, other software for making this particular flowchart. And after that, you need to insert. This is really the beginning of our flowchart, the start, and then you will have the flow line, and then you have this one. This is the input, wherein you get the total amount, the number of years, and the interest per year. And next to that is the flow line, meaning we are going below, no? Next to that is the process symbol, which is rectangular, and you're going to write your formula here. Interest equals total amount times number of years times interest per year. Then after that, another flow line, and you have the interest. So the symbol for start and end are just the same, no? So this particular flow chart, this will be your guide. This will be your guide, your blueprint in making your program. So that is why this is very important to know how to create a flow chart, and also an algorithm. Or probably if you heard about pseudocode, you can also do that. That's another way of making a guide. When you say pseudocode, that is somewhat like a code, but it's not the real code that you will be used in making your program. So this is your another example. Create a flowchart that will display the sum of two numbers. So the algorithm, we have three steps there. First is get the first number and the second number. Then second step, calculate the sum using this formula. Sum equals first num plus second num. And on the third, you're going to display the sum. So this is the equivalent flowchart. So you have the start, the flow line. Then we have the input output, get first num and second num. Then you have the process. Process is the computation. Then we have the output, display sum. Then you have end. Good morning. And next would be example 2. Create a flowchart that uh, computes for the average of two numbers and display the result. So you have the algorithm, get the first number and the second number, and then calculate the average using this formula. So when you say average, you're going to add all the numbers and you're going to divide that with the number of numbers. You have to take note on that, no? So here we have two numbers, so we have to divide that with 2. And after that, you're going to display the average. Very easy. Is Are you with me, Aljane? Aljane Dumanda, thank you for coming. Shout out to you. And that's it, guys. We already end with our flowchart, and we will be discussing next about logical operators. So, logical operators are used in programming to connect two or more expressions. It is also used to control program flow. That's according to Draka's 1997. These operators can only be used with expressions whose results are logical values such as true or false. So there are three common logical operators, the and, or, and not. And is represented by the symbol, or is represented by the symbol, and not by exclamation point. So as you can see, this is the operators, this is the logical and the description. It returns true if both statements are true. And let's say, for example, x is less than 5 and x is less than 10. Let's say, for example, um, if it returns the value of true if and only if x is, let's say, for example, 3. If x is 3, therefore this is true. So 3 is less than 5 and 3 is less than 10. So we could produce an output of true if x is 3. If x is 10, therefore the output would be false because 10 is not less than 5 and 10 is not less than 10. That is equal. So that will be false. Another is, in order for you to get the result of true here, the first statement and the second statement must be true. If there's false, one of these statements, and the output would be false. The only case that it will become true if and only if all of the statements are true. That is the logical AND. And for logical OR, returns true if one of the statement is true. Let's say, for example, here x is less than 5. Let's say 3. 3 is less than 5. Or x is less than 4. 3 less than 4. So all of that are true. So the output would be true. So if one of the statements either in the left or in the right is true, the output would be true. And the logical NOT, you have to reverse you have to reverse the value. Like for example, if the value is false, the result is true. So for example, this one, not x is less than 5 and x is less than 10. So you need to compute first in the parentheses. So what you'll do here, let's say you have 3, 3 is less than 5 and 3 is less than 10. This is true. So when you negate the result, which is true, the output would be false. Okay, so okay, so we have here some truth tables for the end. For true and true, that's true. All of these true, false, false, true. These are our inputs. These are our inputs A and inputs B, and this is our output A and B, logical and B. So you have here, if both inputs are true, the output is true. If one of the inputs here is false, the output would be false. So I hope it's clear. Uh, and let's go next. For OR, logical OR, we have here, if one of the inputs is true, the output would be true. So the inputs here are A and B, and you have to look at here and also here, and this will be our output. Since both are true, so the output here is true. And in here, the output is true because A is true. This one, the output is true because B is true. So the only case it will become false is if both inputs are false. And lastly, we have the not. So A, this is the input, and then the output, not A. So for if A is true, the output will be false. If that is false, the output is true. So we have here an example. So of logical operators. So 5 is less than 8 and 9 is equal to 0. So 5 is less than 8 is what? This is uh, this is 5 is greater than, sorry, 5 is greater than 8. This is false. And 9 is equal to 0 is also false. So false and false, the answer is false. Okay, next, number 2. 7 is equal to 7 and 10 is less than or equal to 2. So 7 is equal to 7 is true, and 10 is less than or equal to 2. So 10 is greater than, so that's also false. So true and false, remembering and if there is false there, the output will be false. So this one is false. And then for number 3, 7 is greater than 8. On the direction of the symbol, no? So if that's like that, so that is the greater than symbol. I hope you're already familiar with that during your high school, no? I think it also in elementary. So if you have problems with that, just review, no? Review on the greater than. This is greater than symbol. 7 is greater than 8. That is false. Now we have the or. 2 is not equal 3, which is true. So false or true. And we have to remember in or, if there is true, the output would be true. So this is true. Okay, so number 4. Not 5 is equal to 5, or not 6 is greater than 6. So this one, 5 is equal to 5 is true. So this is not true. So you have to reverse the not true. So that is false. And in here, not 6 is greater than 6. That's false. Not false. So that's true. So false or true. If there's true in or, so the output is true. That's correct. It's true. And number 5. Number 5, 8 is greater than 6 and 7 is equal to 8. So 8 is greater than 6 is true. 7 is equal to 8 is false. So true and false is false. Not false is equal to true. So I hope you find it easy. If not, you have to review. Let's try to zoom this out. Okay, then next is we have the relational operators. So according to Busby 2018, a relational operator is a programming language constructor or operator that tests or defines some kind of relation between two entities. This is also called as a Boolean expression. A Boolean value can either be true or false. So you have to remember our computer, our machine language is using the binary digit, the bit. So this is just equivalent to the 1 and 0 there would be equivalent to true or false. 1 is true and 0 is false. Okay, so these are the following relational operators used in programming. So less than, take note on the symbol. This is less than, and this is greater than. This is less than or equal. This is greater than or equal, meaning it's either less than or equal. This one is equal, and the last one is not equal. So, for example, 6 is greater than 8. True or false? Yeah, that's false because 6 is less than 8. 8 is less than or equal to 10. So that is true because 8 is less than to 10. You might be questioning, but 8, sir, is not equal to 10. So do not worry with that because this less than, that particular symbol, the range to make it true is numbers 0 or the negative number and 0 up to 9 up to 10 because of this equal, less than or equal. So this is true. 9 is less than or equal to 9. So this is true because 9 is equal to 9. 18 is equal to 6. This is false because 18 is not equal to 6. 18 is not equal to 0. That is true because that 18 is not equal to 0. So we have a summary of our, say we have a truth table for, we have some values here on relational operators, sample value. These are our input. We have the X and we also have the Y here. So, and these are the different outputs for our relational table. So we have the, what you call this one, the less than. This is the greater than. This is less than or equal to Y. And we also have greater than or equal to Y. X is equal to Y. And X is not equal to Y. So what you will do here is you're going to have this number, substitute that on these particular outputs, no, particular operations. So x, so you substitute 1. 1 is less than y. 1 is less than 8. So that is true, no. X is greater than 1 is greater than 8. So that is false. Here we have 1 is less than, yeah, that's less than or equal to 8. So that's true. X is greater than, or 1 is greater than or equal to y. So that's false. X is equal to y. That's false. And x is not equal to y is true. So some techniques here, techniques for solving would be for equal and not equal. So if the answer here is false, automatically the answer here is true. So as we can check that here, false, true, true, false, false, true. And also on this case, okay, you have to continue to solve that for another input combination 10 and 4. So 10 is less than 4, that's false. So 10 is greater than 4, that's true. X 10 is less than, it's false. And X 10 is greater than, so that's true. So 10 is equals to 4, that's false. 10 is not equal to 4, that is true. And then for 2 and 2, so x is less than y, so that's false. X is greater than y, that's false. So if that is equal, so for the less than and the greater than, that is false. Then here x less than or equal, so that's true. And x is greater than or equal, so that's true. X is equal to y, 2 is equal to 2, that's true. 2 is not equal to 2, that's false. And the last example, we have 5 and 3. 5 is less than 3, that is false. 5 is greater than 3, that is true. 5 is less than or equal to 3, that is false. 5 is greater than or equal to 3, that's true. 5 is equal to 3, that's false. 5 is not equal to 3 is true. And let's proceed. I hope you learned that one. So, okay, so now let us try using relational operator on flowchart. So example, create a flowchart that determines the greater number between two numbers entered by the user. So let first number equals n1, then second number n2. So, okay, so when creating flowchart, the first thing that you're going to do is to draw this one and you write start. Or you can also use the word here begin. You can use the word begin. Then you have get N1 and N2. So this is an input, no? Input output symbol. But in this case, we are using the input. By the way, I forgot to include, we have the flow line. So what is this? This is flow line. This is terminal flow line. This is input output. And on this case, the function of this particular symbol is input. So get, the word get means that's an input. Then let's try to zoom out here. Okay. So after that, you have the decision. Is N1 greater than N2? So if that is true, that's you have here the true, then the flow line. Um, then print N1 is greater than N2. You can also use the word here display. No? Display and print are just the same. And the other hand, that's the false. So print N2 is greater than N1 because N1 is less than N2. That's why N2 is greater than N1. So for example, after that, you have the flow line. This is still a flow line, even though the symbol is somewhat like, not like this one. This is still a flow line. So meaning it will goes right here. So remember, the end of a flowchart or the end of program, there's really an end. So that's the end of the flowchart. Okay, so I hope you get this so far, Aljane. So please feel free to do some comments on the particular part of the video, so that if ever you have problem with regards to that, I could assist you, huh? Assist you more if you have problems, if you have questions. Okay, so let's proceed. We have another problem. Create a flowchart that will display male. If the user enters M and displays female, is the user user if the user enters F. Assume all inputs are correct. Okay, so beginning of your flowchart would be start symbol. You draw that. Then you try to write start or begin. Then you get the gender. You get the gender. And so here on this particular part, it will accept M and F. No? Then so we have here is gender. Usually we use the true on the right part, no? But in this example, we use the true here on the left part. So in your solution, if you don't write this wordings here, the true and the false, uh, it's it is assumed that the right part here is true. So on this example, it is written that on this part this is the true, okay, and this is the false. But I advise you to really write the true part on the right side, not on the left side. Okay, so when you're going to have your answer, you use the true part here. Anyway, this is just also correct because this is properly labeled. No, this is properly labeled. So if the user enters M, so it will print male, and if the user enters, if not M, so anything that is not M, whatever it's letter A, B, or C or D, it will immediately print the female. By the way, as an explanation for this one, for the gender, um, you could also consider gender. We have different values there aside from male or female. You have their lesbian for L. You can have their G for gay, B for bisexual, T for transgender, and Q for queer. So that is the gender. Actually, what we're having here is the sex. This is sex, no? The male and the female. This is the what you call this one. Um, but anyway, let's just assume this is correct. But guys, when we talk about gender, we really refer to the not the that's their orientation, what they really want. Like for example, I'm a male, and then let's say I am a gay, or I am a bisexual. That is gender. While sex is about the male and the female. Okay, so let's proceed now to the next. Example 3, create a flowchart that will identify the stages of the age entered by the user. Follow the table below. Display invalid age for invalid input. So, like for example, it will enter um, more than 150, more than 150. So we have 0 to 1, that's baby, 2 to 3 toddler, 4 to 5 preschool, 6 to 12 grade schooler, 13 to 17 teens, and 18 to 150 adult. Okay, let's just assume this is correct. I don't know with 18 and 19 are teens because we are teen. Okay, maybe adult. Okay, let's just assume this particular table because this is what we have. So as the age and the stages. Okay. So we have now our table. So you can see here many decisions, and it begins with what you call this one. This is the terminal. You can write that a start. Then you get the age. Okay, and then is age less than 0? So is age true? If that age is less than 0, so you have to display invalid age. False, so this is less than or equal to 1. So less than or equal to 1. So that's baby. So let's try to see if that's correct. That's baby. Yeah, that's baby. You see here. And then next we have is age less than or equal to 3. That's true. Display toddler. Then false is age less than or equal to 5. Display preschool. Is age less than or equal to 12. display grade schooler. Yeah, grade schooler. And his age is less than or equal to 17. That's through display teens. Okay, display teens. And his age less than or equal to 150. Display adult. And false is display invalid age. Hopefully, you could get the age 150, 150 age. By the way, the average lifespan of Filipino, as what I've read, is around 70 years old. So if you got 150, you're very lucky. Okay, so all of these, you look at the arrows, is going to an end. So the program will eventually end. By the way, you could also write, instead of end here, you can write here stop. You can also use stop here. And structure, because this can repeat zero or more times until the condition is not satisfied anymore. So there are two types of repetition control structure, the pre-test loop and the post-test loop, according to Thomas 2017. So this is the pre-test loop. We have the condition. Then after that, we have the statement here and goes back to the loop. That is pre-test. And the post-test is you have the statement here. It will go to the decision, and then it will go back to the statement. So in the pretest loop, the condition is tested first before executing the statement, while the post-test loop, the statement is executed first before the condition is tested. So yeah. So example of that, we have create a flowchart that will display the user's name 5 times. So we have the terminal start, then we have the flow line, and then the input get name, then we have the initialization. Actually, it's a process. I is equal to 1 because on this particular module, there's no initialization flowchart named initialization. And it's just okay. We have I equals 1. So the value of I at this particular point is already 1. And then there's a decision. Is 1 less than or equal to 5? So that's yes, this is true. So it will display the name. Let's say the name you input here is Maria. So it will display Maria. It will display in the screen Maria. And then after that, I, which is I is equal to I plus 1. So I is 1. So 1 plus 1 equals I will 2. So this will increment by 1. I will increment by 1 at this particular point. And it will goes back here. At this particular point, our I is already 2. So is 2 less than or equal to 5? So that is less than to 5. So it will goes here. And then it will display the name Maria again for the second time. And then here, we have 2 plus 1. I will become 3. Is 3 great less than equal to 5? So that's yes. So we're gonna display Maria again. So that's for the third time. Then 3 plus 1, I equals 3 plus 1, that's I equals 4. Goes back here. Then compare 4 is less than or equal to 5. So that is less than. So that's yes. So it will display Maria for the fourth time. Then 4 plus 1, that is equal to 5. We will now goes back here. Compare is 5 less than or equal to 5. So that's still true. It will goes here. It will display them is will display the name Maria 5 times. So you have Maria, 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 Maria. And it will now be 5 plus 1. At this particular point, I is already 6. Then is 6 less than or equal to 5? So it's no. It's no, and then the program terminates, and yeah, that's it will end the program. So, Algin, how is that? How is that? I hope you're following. And let's proceed now to example number 2. Example number 2. Create a flowchart that displays all even numbers from 1 to 20. So you're gonna understand the problem. So you're going to display the numbers from 1 to 20 that are even. So we know already that even number starts at 2, 4, 6, 8. We're going to display 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Those are even numbers. So we have here start. So this is very important that you have start, or you can type begin here, then the flow line. Then you have the process, A is equal to 0. So we use a variable here, A, that is equal to 0. And we test it here, is A less than or equal to 20? So yes. So we have 0, A equals um, 0, A equals 0 plus 2. So 0 plus 2, A will now become 2. So you're going to display A. This is output. So you display A. So you will here, after that, it will display on screen, A, no? 2, to display 2. And then compare, is 2 less than or equal to 20? Yes. So 2, A is equals to 2 plus 2. So A now becomes 4. So you display 4, goes here. Is 4 less than or equal to 20? That's yes. So we have here A is equals to 4 plus 2. So that is 6. So you display 6. So you will have 2, 4, and 6. And then it will go here 6 less than or equal to 20, and so on and so forth. No, I hope you follow that. You follow that one. For the 6, it will become 8. Display 8. 8 is compared here, and then 8 is added to here. A will become 10. You display 10, and then it will goes here back again. That's loop. It loops, and it compares 10 is less than 20. And yes, it will go here. 10 plus 2, that's 12. You display 12, and it goes back here. 12 compared by 20, it's still less than. So you compare, it goes here, and you have 14. You display 14, and it goes back here. Is 14 less than 20? And that is true. That's yes. So 14 plus 2, that will be displaying 16. Then 16, uh, 16 is compared to 20, and that is less than. It will goes here. So 16 plus 2 is 18. So this you display 18, and it goes here. And 18 less than or equal to 20. You have here that's less than. So it goes here. So 18 plus 2, that is 20. So 20. So you display 20, and it goes here is 18 plus 2, that's 20. So display 20 is 20 is 20 less than or equal to 20. Yes. And um, what happened here? Uh, you have is 20 less than or equal to 20. So that is what? That is yes. So you have A 20 plus 2, that's 22. Display 22. 22 is 22. Uh, is 22 less than or equal to 20? So that's no, it will end. What we have here is we were able to print 22. So there is a problem with this particular problem, no? Because after we have 20 here, so what happened is that it displays 22. It will still display the number 22. So how could we solve this so that our display would only be 1 to 20? So we could change, uh, we could remove, uh, we could remove uh, the equal sign. We could remove the equal sign. So is A less than 20? So that if A is less than 20, let's say for example, we already have 18, right? 18, so 18 plus 2, that's 20. So it will display the 20. And then if it as is A less than 20, 20 less than 20, so it's not less than, so um, it will go here. So let's try to remove, guys. You have to remove the equal sign in order to display the numbers, no? The numbers, um, the numbers for the number uh, 20. Okay, so I hope you get it right. There's a question here, Sir Parts, ano po gamit niyo na software para pang live stream? I'm using Restream. I'm using Restream for the live stream. So here, kindly correct this one, guys. Kindly remove the equal sign. For example, number 2, in order to get the correct solution for that particular problem. Because we find out that if we use this particular with less than and equal to 20, what will happen if we have 20 here is 20 less than or equal to 20? That will go here. And 20 plus 2, that's 22. Display 22. 22 will be displayed. So there's an extra number now. There's an extra number. But if we're going to remove equal here, and let's say we have 18, is 18 less than 20? That's yes. And A is equal to 18 plus 2, that's 20. So we were able to display 20. And that's 20. Then 20 is compared here is A less than, is 20 less than 20? And that will end our loop. So it will goes here. So it will solve our problem, create a flowchart that displays all even numbers from 1 to 20. Okay, so please kindly remove the equal sign here. Kindly remove. It's okay to have problems, no? It's normal. Yeah, just remove the equal sign here on this particular problem in order to solve that's the solution, no? Remove the equal sign. Okay, thank you very much for that. And for example, number 3, create a flowchart that will display the average of all numbers from 1 to 10. So this is somewhat quite difficult compared to the previous one, but you can do that. We can do this. So first, you already know this one. We have the terminal start, and then the arrow, the flow line, and then we have the process. We write here b is equal to 1, sum is equals to 0, and average equals 0. So what's the purpose of having b equals 1? This is used for the counter, and the sum, variable sum, is used to get the sum, and the average variable equals 0, av equals 0. This is used to store the value for your average. Okay, in which that will be your final output, no? The average of all numbers. So after that, we have the flow line, and then we have the decision, and then we ask, is B is 1 less than or equal to 10? So that is less than, so that's yes. And then sum equals sum plus B. So you have sum here. Sum is initialized as 0. So 0 plus 1, sum will be equivalent to what? 1. Okay? I'll try to open some programs here. So how are you, Jeffrey? How are you? You're still there, Jeffrey and Aljane. I gonna have a notepad. Okay, gonna have a notepad for us to. If you have computers, guys, you need to also have this one, the Notepad++. You can use that for your coding or your program. Okay, so we're gonna use this as our okay, so there you go. So we have B equals to 1 and sum equals 0 and B equals 0. So this is our initial values, no? And then for our first loop, let's have what's our B equals to and our sum and our else. Yeah, that's it. Only we're interested only on the values of B and the values of sum. So for the first loop, our B is equivalent to 1 and our sum is you have there sum equals sum plus B. So you write here the value of your sum, which is 0, no? Sum equals 0 plus 1. Sum equals 0 plus 1, that is equivalent to 1. Okay? And your B with this will be 1 plus 1 for this particular part. So B is equivalent to 2. And it will goes here and you're going to compare. Second loop. For second loop, B is already equals to 2. And then you have sum equals the value of sum here, that's 1. And then plus the value of B. What's the value of B? The value of B is 2. So that is equivalent to 3, right? And for B equals our new value of B, which is 2 plus 1, B now is equivalent to 3. Okay? So we have B here. This is our third loop. Our B is now 3. And we compare it here. 3 is less than or equal to 10. And it says that's yes. So our sum equals, is the formula sum. What was our sum here? Sum is 3 plus, what is our b? Our b is 3, so which is, that is equivalent to 6. Then b here is 3 plus 1, it is equal to 4. So this is a counter. Actually, the b, the purpose of the b is counter. It adds 1 to your variable the moment it loops, no? And you have fourth loop. B here is already equal to 4, and here b is equal to 4. Then you have sum equals the value of our sum, which is 6. Yeah, we have the value of our sum. This is the formula, this is the symbol, and the value of our sum is 6. This is the accumulation from the number 1, 2, and the 3. 6 plus, what's the value of b, which is 4. That is 10. And then b equals 4 plus 1, which equals to 5. Then our fifth loop, our b is already 5. And our b here is already 5. And our sum, so 5 is less than or equal to 10, so it will go here. So sum equals, what's the value of our sum? We have here in the fifth loop, sum is already 10. So that's 10 plus b, which is 5. That is equals to 15. And b equals 5 plus 1, which is equal to 6. On our sixth loop, our b is equals to 6, right? We have it here. And the value of our sum, so 6 is less than 10. So it will go here again. So you have sum equals sum plus b. So sum is 15 plus 6. Value of b, that is 21. And b is equivalent to 6 plus 1, which is 7. And seventh loop, and for our seventh loop, b equals 7. Sum equals, sum, what's the value of sum? 21 plus, okay, 21 plus 7, that is equivalent to 28. And b equals 7 plus 1, which is equals to 8. Then for our eighth loop, b is equals to 8. Sum equals 28 plus b, which is 8. Okay. Yeah. 28 plus 8. So that is 36. And b is 8 plus 1, which is equivalent to 9. Ninth loop. So b equals 9. And sum equals sum, which is equivalent to 36. We are on here. So 36 plus 9 equals 45. And b equals 9 plus 1, equivalent to 10. 10th loop, b equals 10. Sum equals Sum equals sum plus b, which is sum is 45 plus the value of b, which is 10. That is 55. So b equals 11. So on the 11th loop, so b equals 11. Is 11 less than or equal to 10? So that's no. So it will goes here. It will no longer go here. So our sum is already 55, and we there's a process here. Average equals sum divided by 10. So that's 55 divided by 10. So 55 divided by 10, which is equivalent to 5.5. Then the value of that is it will display the average 5.5. Then it's we're gonna end. So that's it, guys. I hope so. I hope you get it. I hope you get it, and I hope it helps. Gonna go back here for our material. Okay, so thank you very much for your patience. I hope you got all of the problems. I hope this video will help you. I guess we already have that. So, so there after that you have your learning activity now. So for learning for learning activity, so you have the algorithm. You compare algorithm and flowchart. So how they are alike. So you're gonna write that how they are alike, and then how different are the two. So what's the difference between the flowchart and the algorithm? So that's our activity, learning activity. Then you have this one, the table for activity. Um, so you're gonna take note. These are our inputs A, B, and C, and you need to supply the correct answer for all of this based on your based on what we discussed before. So we have the A or B, B and C, A or B and C, not C, not B, A and C. So you're gonna supply the correct values there. Do not try to guess, no. You try to review the video before. And we also have this input C and G, the different numbers, and we compare that if C is less than G, if C is greater than G, if C is equal to G, or C not equal to G. That is your assessment. And for activity number 2, you're gonna create an algorithm and flowchart. So you have two answers here, an algorithm and also a flowchart to compute for the students. And you have here another flowchart that will display the following based on the age entered by the user. So 1 to 49, you're still young. 50 to 60, you're getting old. 61 to 130-year-old, age less than 0 and age greater than 130 invalid age. So we already have the example on that here. So I hope you can answer that easily. And another problem, create a flowchart that will display sum of all even numbers from 1 to 10. The sum, display the sum of all even numbers. Yeah, this is quite confusing, but yeah, you kindly read properly the problem. So create a flowchart to display the sum of all even numbers from 1 to 10. So this is easy. And you have here the essay. What is the importance of flowchart and algorithm in programming? So you're gonna write that one. And by the way, this is Ma'am Madeline Kahuman, the developer of this particular module. And with the references. Okay, this is the answer for your pretest, and you have to check that by your own. By the way, there's a problem here. It's just okay now. This is stop. No, this is stop. Typo error. So this is stop. So thank you very much, guys. I hope you learned something. You watched the video for Unit 2, Algorithms and Flowcharting. Are still present? Are you still there? Are you still there? Yeah. Okay, so thank you very much for watching this video. Always remember, yeah, I'm gonna change now. Yeah, Aljane. So do you have any questions, Aljane? Do you have any question about what we've discussed? So here's the going to show you, this is the restream. No, sir. Okay. So thank you. So I guess I hope you get it all. You simply, what you will do is you simply review the video. You can review the video. Okay. How about Jeffrey? You have question, Jeffrey? Okay, so this is restream. A question of Jeffrey: what particular uh, restream tool we use? Tool for live streaming. So we use this one, the restream. So you can do that. Yeah, thank you very much, guys. I hope you learned something from our video, and God bless you all. Bye. See you. We still have, by the way, we still have other topics. No, I'm gonna upload the other topics after midterm. Bye, everyone.